Okay, here's the next question I want to show you. Hold on, I'm in the background there. All right, here's the next question I want to show you. So this question is just saying when the area of in square units of an expanding circle is increasing twice as fast as the radius in linear units, the radius is, that's very wordy. So let's break it down a little bit. The area in square units. So square units is always the units of an area. It's always squared. Radius is a length, so that's always linear units. So you can forget about that. When the area of an expanding circle, so the circle is getting bigger, is increasing. So what they're talking about is the rate at which it's changing. So when they say the area of an expanding circle, they're talking about d, a, d, t. It's increasing twice as fast as its radius. So that's implying that the radius is also increasing, and the area is increasing twice as fast as the radius is. So radius is the rate at which is increasing is dr dt. So this is just a simple, make it an equation. So is always means equals, right? So the area or the rate at which the area is increasing is twice as fast 2 times the rate at which its radius is increasing. So that big sentence here, all it means is this. Now it's asking us out for r. So now that we have dA dt and dr dt, we have to make a related rates equation that involves those variables. Well, we're talking about area and we're talking about radius of a circle. So, and you could have started this question this way. Our normal equation that relates area and radius of a circle is area is pi r squared. So now we have to make this a related rates equation. So differentiate both sides with respect to t, as usual. Pi is a constant, so it's 2r dr dt. I'm going to clean it up just a little bit. dA dt equals 2 pi r dr dt. And then I'm going to use my givens. These are my givens. This is dA dt is 2 dr dt, so that's a direct substitution. What I would normally do in this case when I see both sides have a 2 is I would divide it because I can. So I'm going to divide both sides by 2. I forget what we were looking for. To find the radius. So we are looking for r. Now, I would always caution you on this next step. I would say, why don't we just now divide both sides by dr dt? And usually my caution here is this. You can't divide by 0, so don't divide it if you don't know if it's 0 or not. But it does say that the radius is increasing. So dr dt has a value. It's not 0. It is increasing. So it must have a value. So it's perfectly okay to divide both sides by that value. So if you divide both sides by dr dt, you'll get 1 over here. You'll get 1 over here. And over here, you'll get pi times r times another 1. We're trying to solve for r, so just divide by pi. So hopefully that's one of the answers. Let's see. Oh, yes, it is. So that looks promising. All right. So we'll do one more, and that will be in another video.